Here we go.
Awesome. Are you recording already?
Yes, I already started.
Ah, cool. So welcome everyone for today's session of Cloud Native Computing Links. Our community is part of the CNCF community, and you can join and become a member at community.cncf.io/links, or most probably you guys are already part of the meetup group. If you are tweeting something regarding this presentation, or if you would like to follow us on Twitter, it's Cloud Native Links. And yeah, if you do, let's make some noise. Make sure you tag us and yeah, help us grow the community. So just going to the through the agenda today, I'm starting with the welcome. Then not exactly at 5:05, we're gonna have Juraci Paixão Kröhling. Hopefully I pronounced his last name properly. Juraci Paixão is easy because I'm from Brazil and that's it's easy to read, but I think Kröhling is something more German and that's not that easy for me. Then we go for a Q&A. Of course, if you have any questions during the presentation, feel free to add to the chat or to the Discord server. And after the presentation, we go over that. Then at 5:55, we go over some closing remarks. And that's it for today. So a shorter one, just one presentation. As I said, we are part of the Cloud Native Computing Foundation, and we do follow the Code of Conduct of CNCF. If you would like to know all about that, you can take a look into this link, but mainly be kind to everyone, respectful, and everyone is welcome. It doesn't matter your gender, your level, everyone is welcome. And we would like to make this a welcoming meetup. So yep, feel free to reach out and be kind whenever you are asking questions or interacting with each other. The organizers are myself, Juliano. I'm a software engineer at Dynatrace. Here is my Twitter handle if you would like to follow me on Twitter. Mainly I'm posting things related to the CNCF meetup. And with me, I have Jürgen. Jürgen, would you like to say hi?
Yeah. Hi, welcome everyone to this meeting. Really exciting to learn more about the topic today. And I also work at Dynatrace, and I'm heavily involved in a CNCF project, which is called Captain. And I'm a maintainer of this project, and that's mainly what I'm tweeting about, this news and latest developments on the Captain project.
Cool. So if you have a topic and you would like to talk in one of our meetups, please go to tinyurl.com/CNCLinz talk to submit a talk. We are really looking forward to talks where you are sharing your experience. And if you are a company and you would like to sponsor one of the meetups, the same tinyurl.com/CNCLinz sponsor. And we have some packages that you can sponsor, and we will present your company or whatever we agree here during the meetup. You can also join us on Discord at tinyurl.com/CNCLinz-discord. And we try over there to keep the meetup going on. So the discussion and whatever questions you have, we can take this whenever we have a topic that we can take offline. This server is to do that. I have to say that we don't have a active community in Discord, but maybe we can start changing that. We recently sent to all the members of Meetup a form that we would like to improve the Meetup. We saw in the last one that we had a couple of dropouts and not that many people in the Meetup, and we would like to improve that to the community. So we send it's a really short survey, like 2 minutes. You can answer everything, and just asking like what kind of topics you would like to know, the duration of the meetup. So this one is already a new experience. We are doing a shorter one. Usually we were doing for 2 hours. Maybe you guys have any other ideas, like, hey, we could do like 1 hour, but 2 short talks and still keep the interaction in between. So yeah, whatever feedback that you have, it's more than welcome. And finally, today's speaker, Juraci Paixão again. Here we have his Twitter handle, and he's a principal software engineer at Red Hat. And he's also one of the main maintainers of Jaeger. So if you guys know a little bit of OpenTelemetry, and if you are following the open tracing and all that, that stuff that I guess Juraci will talk a little bit, some context about that in his presentation. Most probably you already saw him, or you know Jaeger, and you, yeah. So I'm really excited to have the talk today, because I've been working with OpenTelemetry for a couple of months already. So yeah, and I guess, yeah, Juraci, the stage is all yours. I'm gonna stop my share.
All right. All right. Hello, everyone, and it's a pleasure to be here. I was very pleased to see the backdrop on Juliana's presentation, because I really was hoping that I would be in Linz today with you all, talking there in this beautiful city, but I'm not. So perhaps in, I don't know, in 5 years when this pandemic is over, then we can finally meet each other.
Yeah, definitely you are invited to join us in one in-person meetup, but yeah, wonderful. Hopefully soon.
All right, so let me start sharing my screen here. If I shared the right screen, you should be able to see my slides now.
Yep.
All right, wonderful. All right, so again, welcome everyone to this session here. All you need to know about OpenTelemetry. So my name is Juraci Paixão Kröhling. As Julian already introduced me, I'm a software engineer at Red Hat, and I work on the distributed tracing team. I'm a maintainer on the Jaeger project, and I also help a little bit on the OpenTelemetry front as well. Now, for today, it's all about OpenTelemetry, right? And let me set the expectations here straight, right? So you're not gonna, in the next 30 minutes, in just 30 minutes, you're not gonna become an expert in OpenTelemetry and knowing everything that there is to know about OpenTelemetry. But you are certainly end this presentation here, after 30 minutes, knowing what OpenTelemetry is about and all the projects that are part of this project. And so we're talking a little bit about the OpenTelemetry origins and the projects that gave birth to this project. We talk about the specifications and the standards that are defined as part of OpenTelemetry. We talk about instrumentation, and hopefully I'll be able to show you a demo of how to instrument things and how to run it on from the client to a final tracing solution. And then I explain a little bit about the backend component that we have for OpenTelemetry. We discuss the future, and we have a Q&A at the end. So I'm really looking forward to your questions. Now, to talk about OpenTelemetry and not talk about OpenTracing is quite impossible, right? There are 2 projects that formed OpenTelemetry, and one of them is OpenTracing. OpenTracing, I assume that most of you know about that already, but it was a project that aimed to be the standard for distributed tracing. So a few years ago, like 5 years ago or so, some people were implementing distributed tracing already in some way or fashion, but they saw that the terms that they were using were not defined anywhere. So there was sort of like a problem in communication between people that were interested in the technology, in this concept. So the first idea behind OpenTracing was to get a specification telling, what is a trace, what is a tracer, what is a span. So to set a terminology and set, what is the basics for this kind of technology. Now, once the specification was sort of done, the same people then came up with some semantic conventions. Now, those conventions were mainly made for people to so if you are creating some instrumentation, if you are implementing some distributed tracing in your system, then the semantic conventions will tell you what to record for what kind of data, right? So if you have an HTTP-based service written in Java and you have one written in Python, then the conventions will tell which tags to use, for instance, for the HTTP URL that was called on your service. And the idea there is that once this data reaches a backend, you would then be able to query for this data without having to care about the stack that was used, the language that was used, and so on and so forth, right? So it doesn't necessarily mean that you have to use open tracing libraries to use the semantic conventions, but as long as you follow them, they would be kind of in line with what is expected from you and what other services are expected to do as well, right? So it would make your life easier as an SRE. Now, the third deliverable from open tracing was a set of APIs, so one API per language, right? So we have a Java API, we have a Go API, Python, and so on and so forth. The idea there is that all those APIs for all of those different languages, they kind of have to feel like they belong to the same project. They all have to feel like open tracing. So when I'm coding in Java right now, I know how to use open tracing, so I have this mental model of how it works and what I should do to start instrumenting my application. And if I change my hat and I'll go do some Go, then the mental model is the same. So just the way that I express it in Go is somewhat different. Still, Java has to feel like Java and Go has to feel like Go, but the idea is that you have the same concepts, the same flow for all the languages. And finally, one of the side projects to open tracing were the instrumentation libraries. So the same folks that worked on the APIs and most of the people working on semantic conventions and specification, they started a quest to instrument the road, basically. So we knew, like people developing distributed tracing tools, we sort of knew which frameworks people are using to develop their applications. Right? So we knew that this framework here is very popular, so let's create an instrumentation library for folks using that framework. So that when you add that instrumentation library to your application, you'd get very good visibility into what your application is doing by just watching what the framework is doing. Right? So that's the whole idea behind instrumentation libraries. And the second project that we have to talk about when talking about OpenTelemetry is OpenCensus. And OpenCensus aimed to be the single library for telemetry data. It has a different philosophy than open tracing, so it didn't intend to be an API. It did intend to be like the one-stop shop for instrumentation, for instrumenting your application for telemetry data. So it provided you with both an API and a client in open tracing jargon, and it's all part of one SDK in OpenCensus jargon here. So it is like a batteries included approach. It also provided a backend component called the OpenCensus service, and but perhaps the thing that mostly differentiated OpenCensus from open tracing is that OpenCensus was really made for multiple signals, so not only for tracing. So tracing was the most mature part of OpenCensus, and in metrics were like the second part. Logs were a promise, so were not a part of OpenCensus, but they were planned for. But similar to open tracing, OpenCensus also had instrumentation libraries. Same idea. So people from OpenCensus went there and created libraries that you can add to your application, and those libraries would then instrument the frameworks that you are using. Now, if you've been paying attention for the past couple of minutes, then you kind of realized that OpenCensus and open tracing, they were similar but different. They were competing in some fronts and complementing each other in other fronts. And the people working on both projects, they also saw that a couple of years ago and decided to join forces. And this is the beginning of OpenTelemetry. So OpenTelemetry, as announced a couple of years ago, is the new version of open tracing, and it is the new version of OpenCensus. So if you're using OpenCensus already, then it means that whatever you're doing today with OpenCensus is still going to be supported with OpenTelemetry in terms of instrumentation, right? So if you invested in instrumenting your application using OpenCensus SDKs, then you can just use OpenTelemetry and it should be backwards compatible. You might need to use a shim to make the translation, but the upgrade path should be quite seamless. The same for open tracing. So if you used to use open tracing, there's a shim that allows you to use OpenTelemetry without changing your application. So as a union of both open tracing and open census, OpenTelemetry then provides us today with a set of specifications. For instance, what is a trace, what is a trace, a span, but not only to the tracing part. It also has a specification for the metrics and a work in progress for logs as well. OpenTelemetry inherited the semantic conventions from open tracing and extended so that they also work for metrics and logs. And this is perhaps what I find most interesting, because OpenTelemetry specifies both APIs, but also provides you with SDKs, right? So the same idea from open tracing in terms of APIs. So it is the API where I use, I as a business developer, project developer, I use to instrument my application. And the language-specific SDKs, they're like the Java SDK. It pulls the API library with it and provides me with the capability of configuring my tracer, my client library, with information like where should I send this data to and which sampling strategies are available and so on and so forth. Right, so the language, so the SDKs are what we used to call client libraries in open tracing. And then we have a backend component now known as the collector, the OpenTelemetry Collector. And as you kind of got by now, but OpenTelemetry is really not about only tracing. It's really about all telemetry data, or at least for the moment, tracing, metrics, and logs. We are starting with that, but in the future there might be even other signals. All right, so that's the very basics. And perhaps one thing that I have to mention is most of those, the items that we saw on the previous slide, they are different SIGs, different special interest groups within the OpenTelemetry project as a whole. And each language would then have its own project as well, right? So we have like the OpenTelemetry Java that provides the API, the Java API and the Java SDK. And there is one project, and there is another project for Go and another one for Rust and so on and so forth, right? So really OpenTelemetry is a bunch of projects, really. Now, in terms of specification and standards, we have quite a few of them. And the three most important ones are the API specification, SDK specification, and the data specification. So the API is what I recommend you, developer of microservices, business applications interested in instrumenting your code. That's the one that I recommend you to take a look at. This is like the overview, or it shows you what APIs across all the languages should support. And it tells you how to instrument things, right? So here you do initiate a trace, and then you finish a trace, and then you may add like events or attributes and so on and so forth. So this API specification is really like the one that is the source of truth for all the API libraries out there. The SDK specification is probably not that interesting to you. It mainly says what an SDK has to have to be compliant with the specification. For instance, it has to have this exporter, and it has to have this sampling strategy, for instance, right? So it is not a document that you'd want to read, other than your purpose is to create a computing SDK. And then we get to the data specification, which in my opinion is one of the most interesting aspects of OpenTelemetry. And I should start by making a XKCD 927 reference. And if you're asking yourselves, what XKCD is that? That's this one here, right? That's the standards one. For those of you who don't know, let me, just read this one here for you. The situation before is that we have like 14 competing standards, and 14 whites. It's ridiculous. We need to develop one universal standard that covers everyone's use cases, right? Yeah. And then there are 15 competing standards. So people in on the OpenTelemetry project, they were aware of this. They were aware that, there were standards for metrics. There are thousands of standards for logs. And even though there are so many standards, they decided to create another one, OTLP, so OpenTelemetry Line Protocol. I think the main difference here is that OTLP is both the specification for the format of the data and for the wire. So you specify how the services should look like, both on the client or if you specify how the service looks like, then it's easy to implement both the client and the server. But perhaps the second twist to this one here is that OTLP really should cover multiple signals. So it's not one specification for metrics, it's not one specification for logs, it is really one specification covering all the signals, or at least the 3 signals that we are focusing on right now. Now, the whole idea behind OTLP is that you don't actually need anything else from OpenTelemetry to make your systems interoperable with other Open OTLP-based services. So let's say that you have a client that needs to be really high performant, and you don't want to use any OpenTelemetry SDK at all, right? You don't want any API. You just want to do things in a highly performant way. You can just then use the OTLP specification and implement and unpack the data in a format that complies with that and send this data, following again the specification, to an OTLP compatible backend. Now, in concrete terms, OTLP is really a set of protofiles, like in protobufs, where both the payload and the service are specified. On the other side of the equation, you could be a vendor, you could be someone that is interested in implementing a service that ingests OTLP data, right? So you can also implement a protobuf on the server side and not use any OpenTelemetry code at all if you don't want to. Of course, you are more than welcome to reuse what there is in there, but you don't actually have to. And to me, that's the key, about OTLP, is that it gives you this freedom of using or not the other OpenTelemetry components. All right, so let's talk a little bit about instrumentation then, shall we? And I like to split instrumentation in 3 different types. So the first one is the manual instrumentation. And as an SRE and as a developer that has to manage my own code, that's what I typically prefer for greenfield applications, right? So if I'm starting a project from scratch, I'm creating a new endpoint here, and then I think to myself, what should I know about my application? What should I know about this code here if it breaks in production? And the answers to those questions then become instrumentation. Oh, I need to know, I need to have a span in here. I need to have a trace with this information, that information, and perhaps a metric here that a counter, a gauge, or I need to know that about my application. So that's manual instrumentation. So you with the business knowledge, you add telemetry data on the right aspects of your application. Instrumentation libraries, they're very good. If you're relying on, they're really good for some layers, like the HTTP layer, where you get automatic instrumentation for every HTTP request that comes in, and for the HTTP clients or clients in general, where you propagate the context whenever you call another service, right? So the instrumentation libraries, they can do this context propagation automatically for you. For things that are in between, they are also useful, but they can be noisy, right? So you really have to think very thorough what kind of instrumentation libraries you want to add to your application. But they exist for pretty much every popular framework out there. And instrumentation, automatic instrumentation is a type of instrumentation that you have typically when using things like Java agent, right? So you're changing the bytecode of the application, you're changing the way that the application runs without actually having to change your application, without having to add the instrumentation libraries to your project, right? In practice, automatic instrumentation would just reuse the instrumentation libraries from the step before and add them automatically to your application without having, again, to rebuild your application. So they're very good for legacy applications, not only, but they're really lifesavers for legacy applications where you don't really want to touch or rebuild the application just to add instrumentation. All right, so I have a demo prepared for for us here today. And I'm going to use Quarkus, right? So I'm going to go to code.quarkus.io, and Quarkus, for those who don't know, is a Java framework for building cloud native applications. All right, so let me add here. So DE, actually, let me add here OpenTelemetry demo. Right, and I'm selecting the JAX RS layer for my endpoints, and I'm selecting here OpenTelemetry, both the base extension and the Jaeger exporter. All right, let me get my application, save the file, let me copy this code in here. And for my terminal, so let me close this one here. I was doing something else before this presentation, so that's okay. So let me go to the download. Oh, downloads. And all right, so I have the demo here. So let me, it's a zip file, unzip, quiet, and OpenTelemetry demo. All right, so I open my code editor. I want to import my Java project in here. And let me close those tabs. Let me open a terminal. So create a new terminal, and I would let the application build while we take a look at the code. All right, so this is pretty much a boilerplate, and there is nothing really interesting in here. For those of you who know Java, it is a standard JAX RS resource. For those of you who don't know Java or don't know JAX RS, this is a REST endpoint. Basically, that's all you have to know. And whenever a slash hello REST easy is called using a get method, then I'm just returning the string in here. Right, so that's pretty much it. The only thing that I have about OpenTelemetry and Jaeger in my code are really those two dependencies, right? And those are Quarkus extensions. Now, even though the demo here is using Java and Quarkus, all the concepts that you're seeing here, they apply to other languages where available, of course. I mean, there are some languages that you just cannot do automatic instrumentation. But for the languages that do, you have those those types of libraries in there. All right, so let me create a new terminal here. Let me start a Jaeger instance. So I'm starting Jaeger and exposing 166.86, which is my UI, and 14.250, which is the gRPC port. And yeah, so that looks good. All right. And then, is my application running? Yes, it's running. All right, so let me create then a new here and see if we can get to localhost for my application. So 8080, what was it again? Hello, REST easy? Yeah, okay. So let's try to open Jaeger. Oh, we have one service here already. Okay, OpenTelemetry demo, 5:31 p.m., which is that one that we ran on from my code editor, and it took 26 milliseconds. If I open this here, I see that it was a span that was generated for me by Quarkus. So for every single HTTP request that my application receives, I have a new trace. And what I can do now is, so that's very good, right? I mean, without doing anything, without not even writing any code, I do get some instrumentation ready for me. And I can see that in Jaeger already. I don't have to configure anything if I'm using the standard configuration. All right, that's helpful. That's automatic instrumentation for you. So we talked about instrumenting the frameworks that you are using so that you get very good visibility into what your application is doing. And this is exactly that. So it is giving me latency information and some environment information, like what is the process that it's running. So it's what is AP and what are the libraries that I'm using, without having to do anything. Right, and I get this one here took 26 milliseconds, and if I run another. From my code editor, if I run another curl call and refresh here, then I see the second trace in here. And I see that it took like 2 milliseconds to reply to that curl call. All right, now how about then we add some manual instrumentation here, right? We can come in here, see some Java magic, or not so much magic if you know Java or if you know CDI, but I'm going to inject a tracer. So tracer from the OpenTelemetry API. So tracer, and I then go to my code in here, and I can just span. Span is my tracer, and I span builder, and I add a new name for my operation here. So my operation can be named hello from Linz, right? Which I was hoping to do if I were there with you. So start span, and okay. So now I have a span. I might need to organize imports, and I'm talking about the API for span. Yeah, and in here I would do something interesting. So what really my application is doing. And this might be like a complex algorithm that takes a long time. And I can then here, once my processing is done, I can then just call end. Right? And I save it. And on my first process, let me just restart Quarkus. In theory, I should not need to restart Quarkus. Quarkus has a hot reload, but there is a small bug right now with a hot reload and OpenTelemetry. So if I run a couple of other curl calls and I go to Jaeger, I should see now 4 traces, and the third one took 28 milliseconds, and the fourth one took again around a few milliseconds, so 3.4 milliseconds. And if I open it, I see that the trace has 2 spans: the one from the instrumentation library and the one from my manual instrumentation, right? I could, of course, have added a few tags here as well. So if I detect that this processing here is being done in the name of a VIP customer, I could then be adding a tag here saying, VIP is true, or I could be adding the customer ID in here, so that when my customer calls and tells me that there is a problem, I can then just come to Jaeger and run a query setting the tag for the client ID XYZ, and I see all the traces that client has performed on my application. Right, so that's instrumentation. That's a little bit also about distributed tracing in general. I hope you forgive me for going into that into those level of details. But yeah, that's the instrumentation part. And we also have to talk a little bit about the backend, right? So OpenTelemetry provides you with a backend component called OpenTelemetry Collector. And the collector really is a pipeline for telemetry data. And as a pipeline, it means that we have 3 main components. So the receiver, the processor, and the exporter. So receivers and exporters, they can be active or passive. So in the case of receivers, it is active when we are going outside of our process to look for data. So when we are acting like Prometheus and scraping some data, or when we are getting what is the host CPU usage right now, or the host memory usage right now. And I add information to this pipeline, and then they get, they flow through this pipeline. Now, they are passive when I open a TCP port, for instance, and I wait for clients to send data to me. Now, once data has reached the beginning of the pipeline, they are sent to processors. I can have multiple processors, and they can be chained, of course. Now, the thing is, a processor can define what to do with this data. So should this flow here proceed, or should I just add this information somewhere to batch it perhaps, and then stop processing, from that line, from that thread? Or if I'm doing some sampling, I can decide to just drop the data, right? Or perhaps I know some environmental information, like which cluster I'm running on, which availability zone, and so on. And I want to add more metadata to each single data point that is coming to my system. Right? I can do that with processors. And then finally, we have the exporters. Again, active or passive. Active when an exporter sends this data out of the process actively, like to some backend. In our case here, it was directly to Jaeger. But it can also be passive in the sense that it can then just expose an open metrics endpoint, for instance, and then a Prometheus-like service can then scrape this data out of the exporter. Now, in terms of receivers, we have receivers for quite a good number of technologies. And in the core of OpenTelemetry Collector, we have things that are either open source, or actually not either, but that they are both open source and useful to a lot of people, right? So a Jaeger receiver, for instance, belongs to the core. It's open source and it's useful to a lot of people. The same for OpenCensus, OTLP, Prometheus, and Zipkin. Now, we have a second distribution of the collector called the collector contrib. And in there we have either things that are open source, but perhaps not useful to a huge number of people, like the Kubernetes cluster receiver, for instance, or things that are vendor specific, right? The same idea applies to the core of exporters. So in the collector, OpenTelemetry Collector distribution, we have in the core set of exporters, we have like File Exporter, Jaeger, Kafka, Logging, OpenCensus, OTLP, Prometheus, Zipkin. Again, fulfilling both the requirements of being open source and useful to a good number of people. And on the contrib, we have pretty much one exporter for every big player in the observability area, right? And plus a few things that are open source or very specific to OpenTelemetry Collector, like the load balancing exporter, but they might not be useful to everyone, right? In other words. All right. Now, then, when should I use the collector? So, and this is a question that I get quite often, and the answer sometimes is just that, you just don't use the collector. I know how it sounds, but if you have a setup that works already, if you don't have the need for the collector, if you don't know if you need the collector, you probably don't. And I'm telling you when you need, right? So stay with me there. So if you have a Prometheus setup in there and you have your business application with a Prometheus-like client, like Prometheus client or OpenTelemetry client or something that exposes data in open metrics format, and you have your Prometheus configured to talk to your application already, then you don't need a collector. You are happy with that. It just works. The same with Jaeger, right? So if you have your business application instrumented using the Jaeger client or some OpenTelemetry client, and those clients, and they're correctly sending data to Jaeger, and if it just works for you, then it's fine. You don't need the collector either. Now you start needing the collector when your setup is somewhat more complex, when you don't want to manage the configuration for the client on each single service that you have. So you can leave the configuration to as it is, and you can then manage some aspects of that configuration on the collector. One way of doing that, or in one scenario that it comes useful, is when we have a Prometheus and a Jaeger client as part of your business application, and they are configured in a different way from each other, right? And then you send data from Prometheus to, or you expose Prometheus or metrics data to Prometheus, and Jaeger sends data to Jaeger. But then you realize that your metadata is kind of not really aligned. So you can use OpenTelemetry Collector there to align the metadata for all the signals, basically saying, I know that I'm running on this pod in here, and I'm now making sure that my metrics contain the pod information and my tracing data contains my pod information. So that when I see an increase in error rate and I see that they all belong to this pod, then I can go to Jaeger and do a query for all the traces coming from that pod. Right? So you can use the OpenTelemetry Collector in here as an equalizer. Now, you can also use the collector as a proxy or as a multiplexer, right? So you have your business application. Again, it can be with Prometheus and Jaeger or with OpenTelemetry client, it doesn't matter. And data then reaches the OpenTelemetry collector. And from there, you can decide to first send your data to Jaeger, a local Jaeger instance that you have somewhere that you own, so that you still own the data. But you may also decide to send the data to other two vendors, perhaps to compare them, perhaps because you do have contract with both of them, and one is better than the other in some aspects, and you want to send the same data point to different places. So you can use the collector for that. One type of deployment that has been more and more popular is or the ones that I actually recommend in a lot of cases is to make use of sidecars. So you have your business application, again, either with OpenTelemetry client or Prometheus plus Jaeger, and you have on the same pod, you then add a second container with OpenTelemetry Collector. The idea being that you can offload your telemetry data quicker to outside of your business process. And you can then set, we're talking about Kubernetes here, right? So you can then set for that container, you can set specific limits and requests so that telemetry data doesn't end up killing your application, basically. And then from that pod, or from that second container, you can then send data either directly to the destination, like to Jaeger and to the vendors that, using the example that we had previously, or you can send data to a central collector that then is able to make enrich this data in even more, or perhaps make other processing there, right? So we can decide to do some tail-based sampling there, or things like that. All right, so that's pretty much it for the collector side. And before going to the Q&A, I'd like to talk about the future of the project. And the present is that the distributed tracing parts are GA already. So the specification for the tracing parts are done, basically. Metrics are following next, and logs are coming after that. Now, some SDKs are GA already, like the Java, the Python, and the .NET, others to follow. If you're using Kubernetes, take a look at the Kubernetes operator. It is in development, but it is useful or usable already. Perhaps some extra information for you is that for the Jaeger v2, we are changing the agent and the collector to be based on the OpenTelemetry Collector code, right? So we should then have the agent and the collector focusing on the Jaeger specific parts and delegating the commodity parts to the collector. And eventually the Jaeger clients will be deprecated in favor of the OpenTelemetry SDKs. We cannot do that right now because we have some features on the Jaeger clients that are not supported yet or are not defined by the SDK specification yet. And they have to be before we can recommend people to move from Jaeger clients to OpenTelemetry SDK clients. If you don't use those features, such as remote sampling, for instance, then you certainly should start looking into OpenTelemetry SDKs instead. All right, some key takeaways from today. I hope that you learned something from this presentation here today. From my view, it is all that you really need to know about OpenTelemetry so that you can start asking the right questions. And asking the right questions is a very good start, if you ask me. So takeaways. So OpenTelemetry is a collection of smaller and independent projects. So just because you use the API and APIs and SDKs, that doesn't conflate in using, that doesn't mean that you have to use OpenTelemetry Collector. And using the OpenTelemetry Collector doesn't mean that you have to use OTLP, for instance, right? So you can just have the collector with Jaeger on one side and Jaeger on the other side, or Jaeger to Zipkin, or Zipkin to Jaeger, and so on and so forth. You don't have to use those projects. They are independent, and they're meant to be independent. OTLP is a data specification, and it is the format and the wire. So sometimes when people say that OpenTelemetry, they really mean the OTLP. So it's probably wise to use the right terms there. And as a developer, as someone writing, code that needs to be instrumented, you probably care most about the instrumentation aspect of OpenTelemetry, so the API, SDK, and so on. As an SRE, you probably care both about the instrumentation side and the collector side. And as a vendor, if you're building an observability project, a solution, or things in this area, then you care most about the data interoperability. So OTLP would be probably most relevant to you. Perhaps the collector as well, but that depends really on your strategy. And the tracing part is the most mature part right now. Metrics are coming up next, and logs are coming after that. All right, so with that, I'm open for questions if we have time and if we have questions. Thank you very much.
Thank you very much, Juraci. That was awesome. And we did got a lot of questions.
Wonderful. All right. I see some questions here on Zoom.
Yeah, I already put them in earlier whenever they were coming in from the community. And I can also kind of moderate that. And I think you addressed it, but the question was coming in quite early. How does OpenTelemetry relate to Prometheus?
All right, yeah. So we have, OpenTelemetry, again, is a set of projects, right? So when we talk about the data format, then it doesn't relate that much. There is an effort right now to streamline or to make OTLP closer to OpenMetrics in some way, or to try to address both as part of the same specification, or make them at least interoperable. So that's one aspect. The second aspect is more really like Prometheus, is about really the backend. And in that part, it is comparable to like the OpenTelemetry Collector, which is the backend component for OpenTelemetry. And if you see the collector as only the pipeline, then you can see that it either replaces Prometheus when it scrapes data from your application, but it also sends it or makes data available for Prometheus when it exposes a Prometheus or an OpenMetrics endpoint, right? So it relates to Prometheus in some parts. It doesn't replace Prometheus at all. So we don't have a UI here. You cannot run PromQLs on OpenTelemetry in any way. It really is just like the middle field for Prometheus. And on your application, if you're instrumenting your application, you can use the OpenTelemetry SDKs and configure a Prometheus exporter or OpenMetrics exporter, so that a Prometheus instance can then scrape data out of your OpenTelemetry instrumented application. So there's quite a lot of integration points with Prometheus here.
Cool, thank you. Second question was if you can also share the slides if that is possible.
Yeah, absolutely. Yeah.
Perfect, thanks. So we will make them available later on the community page on meetup.com and also in Discord. Probably tweet them.
Yeah, I'll probably leave a link on Discord, and I'll just upload as well to some website and make it and announce it on Twitter as well. So awesome. You can get the slides from both places. Yeah.
Cool. Thank you.
There was another question.
Yeah, there is another question. Maybe it was mentioned, but is there a default backend for OpenTelemetry?
No. OpenTelemetry is really agnostic in the backends, right? So it doesn't tell you which backends to use. It makes a lot of backends available to you, but it doesn't really recommends or it doesn't require any backend for you. And I assume you are talking about the OpenTelemetry collector in here, right? And because for the collector, you do have to get data from somewhere and you send data somewhere. I, of course, recommend using Jaeger for the tracing parts, but you can choose, there are a lot of vendors out there that you can use with OpenTelemetry Collector. The same for SDK, so that most of the SDKs, they have a small set of exporters that you can use already, like OTLP exporter and Jaeger exporter and Zipkin exporter and Prometheus exporter, which then just makes them available as a OpenMetrics endpoint from your application. And so from the instrumentation part and for the tracing aspect of OpenTelemetry SDK, I would recommend you to start with OTLP exporter, right? So sending data in OTLP format somewhere. And if your destination is Jaeger, then you place an OpenTelemetry collector in between that makes the conversion between OTLP to Jaeger. That should make it easier for you to, I hope you don't move out of Jaeger, but if you decide to move out of Jaeger, then it makes it easier for you to choose other solutions. On the metrics side, it's perhaps a little bit harder to decide on that because Prometheus is so prevalent that, or OpenMetrics for that matter, that makes it harder for me to recommend using OTLP for the metrics side as well. So I don't really know. My area is really the distributed tracing part, and I would recommend you to try both. Try OpenTelemetry OTLP for metrics and Prometheus exporter and see what fits better for you. But so again, to answer the question, there is no default backend for OpenTelemetry Collector.
Thank you. And then we have another question. What are some non-JVM tools that are commonly used for event stream processing of OTLP data?
All right, that's a good question. I'm not aware of any, even for JVM tools, right? So I'm aware of a Kafka receiver that can be used with OpenTelemetry Collector. But if we're only talking about OTLP data, so not the collector itself, I'm not aware of any tools that can process OTLP data in a streaming fashion by default. If you do some research and if you find like a good tool for that, do let me know, because now I'm curious as well.
Cool, thank you. I think there are no more questions here in the chat. If anyone has a question, just feel free to unmute and just ask the question right away.
Juraci, I would like to ask you something. I think we are on the top of our, I don't know if we have time, but just to maybe know your insights about that. Wouldn't it be better to OpenTelemetry focus on the OTLP exporter, and then let the rest of the community just ingest those traces? So then, because in your sample you use the Jaeger exporter, but I know that I can configure the OTLP exporter to send data directly to Jaeger, right? So
well, continue. Yeah.
Well, yeah, maybe I need a collector in the middle. Yeah, you're right.
Right.
But it wouldn't be easier, I mean, community-wise, to have some standard on the application level as well, and then like talking about maintainability of the project and growth of that.
Yeah, absolutely. So there was a discussion about this very topic on the OpenTelemetry Collector side, right? So if you're talking about the SDKs, then if you're doing a greenfield application, and if you have the possibility of using OTLP exporter because you have an OpenTelemetry Collector somewhere, or an OTLP enabled backend, then that's what I'd recommend you to do, right? So on the SDK side, if you can use OTLP, then do it. On the collector side, it is like a double-edged sword, right? So if we don't have like the Jaeger receiver and Jaeger exporter, then we don't have we cannot consume and we cannot send data to Jaeger, because Jaeger does not support OTLP right now, neither at the backend or at the client side. And the way that it is done right now, the collector can be placed transparently between Jaeger client and Jaeger server or Jaeger backend. So I can then do things like multi-tenancy, I can do authentication, I can do tail-based sampling at the collector alone without having to use any OpenTelemetry's features from the clients or anywhere else. So my Jaeger clients can still send data to a service that it believes to be Jaeger, but it's an OpenTelemetry Collector. Then I can do some tail-based sampling there and send data to Jaeger, which then thinks that it's talking with a Jaeger client, but really is an OpenTelemetry Collector. So I think it is a key aspect, or a key bootstrapping aspect or feature for the OpenTelemetry to have support for multiple receivers and multiple exporters. That said, there is a movement, especially among vendors, to add OTLP native support to their APIs. Right, so more and more people are replacing their OpenTelemetry Collector exporters, and by making OTLP native on their side, so that they don't have this code here in the contrib that people have to use their exporters. They can just use OTLP exporters, just like any other service. So there is a movement going to this direction, but there is value in consuming and exporting data from multiple sources and to multiple destinations as well.
Cool. Thank you very much. And by the way, nice host name. I saw Guaraná on the, on the trace. For those
it's a powerful machine,
yeah. Guaraná is a soda from Brazil. So yeah, just an internal joke from Brazil for Brazilians. Cool. Jürgen, so yeah, so to everyone that is in the call still, if you guys have some 2 minutes, please just answer the form that we sent. If you didn't get, we posted, Jürgen posted the link on the chat and also in the Discord channel. We're gonna wait a little bit. I would say 1 more week or 2 weeks before posting the next event, but we do already have the next presenter, so that's already good. Jürgen, any other news that you would like to share? Or
no, thanks everyone for joining for today, especially thanks to our great speaker. I have troubles pronouncing. I can pronounce the last name, I think, really good, Kröhling, but with the first name I really have trouble. So I'll leave it to Giuliano to thank you again, and hopefully see you all also in the next edition of this meetup.
Thanks everyone. Thanks Juraci, and yep.
Thank you for having me. Yeah.
It was really nice. Thank you.
Thanks everyone.
Have a nice evening, and see you all next month.
Thanks everyone.
Thank you.
Bye.
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 Thank you.